Okay, hope this is working. This time we are gonna be working on a new firewall kind of thing. So I read about this cool thing called eBPF yesterday. This came out of the old Berkeley packet filter, and then this is an extended version of that, which is a very low level thing, which is essentially meant to act as like a sandbox or a VM inside the kernel, so I can write programs, and then the eBPF chain can essentially run those programs. The eBPF VM, you can think of it, can run the programs in the kernel, and that is supposed to be massively faster than something like IP tables, um, and more scalable and stuff. So I don't know much about it. I haven't read much about it, to be honest. I read like the basic, like, getting started section of the eBPF website, and then I'm like, okay, let's just get into it, start prototyping and making something. So that's where we're at. I found this cool um, feature of my books where I can like scribble over something and deletes that. Just thought that was cool. Anyway, what do we want to make? So in a classic kind of firewall-ish scenario, what usually happens is that you have your packet coming in, um, and a bunch of things happen, like NAT stuff, Mangle, chains, stuff like that in IP tables. But let's forget that. Let's just talk about filtering. So your packet comes in into the um, your firewall layer, right, which is your IP tables layer, and your packet is uh, because this is coming into your system, and it's supposed to be, you know, yeah, it's just arrived. It goes to what's called the input chain, and from there you have a bunch of rules, a table of rules, which based on usually the IP, but you can have multiple modules, like for example contract, which tracks a connection, stuff like that, which you use to make a decision on what to do with this packet. So usually you have, accept. You might accept a packet. That's not how you spell accept, but you get the idea. Or you might drop a packet, or you might uh, reject it. And then from there, if you accept it, it goes all the way to the application, or maybe you're forwarding it to some other interface and stuff like that can happen. Um, if you're dropping it, the packet is dropped. If you're rejecting it, you actually send back a reject packet, um, which will come, like, essentially the difference between these two is that if you send a packet and it's dropped, your your you'll basically wait on that connection forever or until it times out. And if you send a reject back, then your connection will be rejected immediately, and it'll give you like a connection reject warning, something like that, right? So this is how it works in IP tables. So why is this relevant? Essentially, what we want to do is something similar to this, but we want to use eBPF. Now, if you watched the other video that I made, which I didn't follow up on, I should probably do that, but regardless, um, yeah, if you watch that, the kind of one basic idea there was that you should always try to improve on like an existing idea, and you should put your own twist to things, essentially, right? And here, the twist that I want to put is that I want to add like a policy based system for this. So you might think of it like security groups on AWS or something like that, where you give them a list of policies, um, and then you compile those policies somehow into like a set of rules, and then you apply your packet filtering on those policies. So you can imagine, for example, that you have like an inventory of hosts that you're trying to target, um, and each host has multiple tags on it, which can be like IP, or um, it can be anything, right? You can make custom tags for whatever details, and then you write a policy that says, hey, some if you're on, um, if the current machine is tagged, tag one is X, and if the packet is coming from a machine that has a tag 2 of Y, then accept it. Otherwise, uh, reject, or something like this. In general, for like normal traffic, you might want to drop it because you don't want to necessarily show that there's anything running or something. There's a lot of controversy around that, but not gonna get into that for now. Yeah, so you might make like a policy like this. I haven't really thought about what the policy structure should be. There might be like standard ways to define these. We'll look into that later. But for now, step one is let's set up our environment and run like a basic um, filtering script. Also, something else that I want to do is I don't just want to filter, right? So another really cool idea would be, and this is thinking about it from like a production standpoint, is if I could create a policy and put it in like a test mode, and it would basically just look at what's actually happening on the host versus what would have happened if the policy was there, and show you the differences that, hey, this traffic which is currently being accepted would now be rejected, or this traffic which is now being rejected would be accepted. And that might seem a little bit crazy to you, that you can have things that you are rejecting, but then you say, okay, I will accept this. But that's because of the flow of how eBPF works. So eBPF has hooks that you can put before before it enters the IP table stack. And then it has hooks. We are assuming that there are no competing eBPF plugins that messes up our checks. I think that's a fair assumption to make. But yeah, you'll basically check before you make any changes. Before you make any changes, as in before your eBPF does anything. After your eBPF does stuff, and then after IP tables does stuff, you'll take logs from three different places at three different points in your network path, and compare between them to see, hey, how will your policy impact the current network configuration of your system. And that's very, very helpful when, for example, you want to do a large scale deployment. You can think of actually writing a policy, putting it in test mode, and then you can give like a nice chart explaining, hey, this is how your networking will now change, or something like that, right? For this, you need to use some like logging mechanism, probing mechanism, which eBPF does have some support for, because, well, on their main web page, they say, hey, you can use this for observability, and if you can use it for observability, I'm assuming you can do this as well. That's the depth of my knowledge about this right now. But okay, cool. Let's get started with the technical stuff. First is setting up like the tool chains and stuff that are required, and setting up like a basic filtering demo. I will try to do both of these in this session, but I have a Green Day concert right after this, so maybe I'll cut it a bit short. I'm not sure. So I did a little bit of research on how the actual tool chains for this look like. It looks like the official tool chains, there's one for C and another for Golang. And I am not comfortable writing C. It's a very old language, and I know I shoot myself in the foot with it very, like, a lot. It's not going to be fun. But I am familiar with Golang. But it looks like the actual packet filter part, right, the actual like stuff that runs on the kernel, that you cannot write in Golang, because Golang, as you would know, is not like an LLVM based thing. It's based on like its own toolchain, which it forked off. I forgot. Sorry, but it's not based on LLVM, so it can't. There's an LLVM toolchain that basically makes it so that anything that you write in like a basic language, you use the LLVM toolchain to compile it into the VM code, right? The byte code that you can run on the eBPF VM. But because Golang is not a VM, it expects you to either write C code for the eBPF kernel plugins, or it expects you to just write the direct assembly, the direct VM assembly, and then you embed that into your Golang program. which I don't want to do. I don't want to write either C, and I definitely don't want to write assembler. So I found that there is a Rust library called Aya, which does um, this thing, which provides you, gives you an interface to the LLVM bindings for eBPF, and that is probably what I'll use. I don't know if it's a good idea. I don't have much experience in Rust, um, but this seems like the best way to go. If this doesn't work out, then I might have to bite the bullet and go back into C. I mean, I can write C. It's one of those languages that you have to learn, like especially if you've been coding for a while. I can write C. I don't trust myself writing C though. So um, that's where we're at. Let's see what we can do. I, I might go silent for a while. Should find out how to add some background music to this. That would be interesting. Also, if you don't know the setup, this is just my book's screen projection. It's nothing weird. So I should check if I have Rust installed. Which I do. Oh, fantastic. Okay. I need to update Rust. This is where we are starting, folks. I genuinely don't know what tools I have installed. This is what I mean when I say I'll start from scratch. Rust is going to be okay, blah blah blah. Okay. This guide assumes you're comfortable using the Rust programming language. So. I've written and debugged Rust applications on a desktop environment. You should also be familiar with the idioms of the 2021 edition. What? Okay. I'm gonna assume that I know this. I don't know, but okay, let's go. Rust up install stable. I think I've done this already, but no issues running that command once again. Once you have installed this, you must also install BPF linker. The linker depends on LLVM. Okay, I might have to install LLVM. Is that cargo install? Okay, I might have to do this. So let's do that. Right. Oh no, 7 outdated formulas. It's not many. Should be okay. LLVM sys prefix. Okay. Okay, should be good. Let's do that. Something that I haven't thought about yet is how I'm going to test this, because I don't have a Linux VM. I might just have to spin that up on AWS or something like that. Okay, could not compile LLVM sys due to... What is your error, sir? No suitable version of LLVM was found. LLVM sys 191. LLVM sys 191. I don't know if that worked, but let's hope. Damn it. Okay. Right. Oh, this might be because of a path issue. Nope. Group. Let's see what happened. Unknown command brew prefix. Oh, it looks like, oh, brew minus minus. Lol. 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 LVM. Bin. Nope. Hmm. Man, managing dependencies is not fun, is it? LVM. It does look like LVM is part of the default toolchain, so maybe I can just do this. Well, okay, I tried. Oh, it's trying to install LLVM sys 191. That might be why. I'll think about it. So maybe what I need to do is, okay, let's Google it. This should be the easiest way. That might be helpful. What's not going to be helpful is that any LLVM config not found. Oh no. Oh wait, that's not right. Nah. True. Prefix LLVM. And then I should be able to go there and then do a LLVM or a bin slash LLVM. Config. Version maybe 18.1. So let's see. Brew install LVM 19. Let's check the actual brew site. That might be better. Let's see. 18 is the latest version. That brew supports at the very least. Okay. This is why you're here for, isn't it? See me struggle with dependencies. Pretty sure the issue here is that it's expecting LLVM 19. So let's search LLVM 19 Mac install. Does LLVM 19 even exist? It doesn't. The latest one is LLVM 18. So what the heck is that? Oh, this is LVM sys now. LVM sys. Plus crates maybe. Let's see. 181. Wait, why are you trying to install 191? LVM sys 191. It's a release candidate. Dependencies. I've never used this. I don't know what's going on. GitHub. GitLab. Okay. I think this is gonna be protected. Huh. Okay, I think that's supposed to not be 180, but okay, let's see. Yeah, this is trying to install LVM sys 191, which might be the issue that we're having here. Only thing I can think of is that this thing is somehow, oops, it's not gonna work. Will BPF filter. Come on, crates. Yep, dependencies. There, that's the issue. Okay, let's try to get an older version. There we go. It's probably gonna work. This is out 25 days. So that should have worked, but it's clearly not. So I'm gonna do that. 9.12, I think it was 12. This time it should be using VM sys 180. There we go. That's very interesting because how did this survive compilation? This requires a version. Oh wait, what? This version was yanked. Interesting. What is this? Dependencies. Okay, no idea. But hopefully this won't bite us later. Might be a lot of hope, but gotta do what you gotta do. Cool. Go generate. This should just work. See, this is why I don't use Linux. I use Mac OS instead. It's because there are bugs on Linux, right? Makes it very hard to do your work. I'm joking, just in case anyone thought I was serious there. Hey, while we're waiting on this, I'll tell you the story of why I'm using a Mac and not Linux. It's because I got a Asus stuff or something like that. A nice gaming laptop with a 4070 in it. I use laptop exclusively. Sorry about that, but yeah. So I got that. I installed, I think, Pop OS on it. This was before Cosmic. And 2 days in, it was using software rendering for YouTube, which is absurd in 2024. I don't care what operating system you are, I expect you to use especially if you're like Pop OS, which is supposed to have at least good good, like it's supposed to work well with NVIDIA. I got the NVIDIA version. It's supposed to come with good NVIDIA drivers, and it just didn't use it, which was infuriating. And again, I had NVIDIA SMI, and NVIDIA SMI told me that everything's supposed to be good, but sometimes things don't work. Okay, so firewall. I don't know how the project structuring is going to look in here, so I'm going to call this like kernel module, I guess, or um, it's called daemon, right? Daemon, because it's going to be the piece that runs everywhere. What type of eBPF program are we? So I did some reading into this, not from like, not from like from literally right here. Like if you go to the working with the IO section, I think, not there. Program types, that one. I read what are the different types of programs. Uh, I really want to know what trace points are, but this is a work in progress, so I don't know what they are. And then probes are supposed to be like probes, right? And if you remember the little diagram we had earlier, uh, oop, just starting the screen share on this. Start share. Go back. Do we need to refresh? No. Come on. Okay, why are you not working? Oh, there we go. Oop. So if you remember this little diagram, so we need to use probes, I think, for these kind of operations where we are supposed to take the logs of what's happening. But I do know for certain that we are supposed to use an XDP type, extended data path, or express data path, for the actual tracing. So let's do that. Sorry, for the actual firewall, right? So let's do that. And we should have our project structure. Okay, cool. Let's see what's inside this. Oh, our daemon folder has a daemon inside it. I don't know if this is just taking the same name as that, but I assume so. So let's just go through what's going on there. So cargo terminal just says that it doesn't really say much. It just says, okay, this is a workspace. So it says there are 3 applications here. So there's daemon common and X task. Let's look at what those are. Git ignore is usually helpful because it shows you what our build artifacts are. The debug target and backup files. Oh, Rust format, interesting. Again, I have never used Rust before, so I'm sorry, I don't know what this is. It looks like some linker instructions or something. It's a Lisp. This looks like a Lisp, and I think LSP is short for Lisp over there. So this seems to think it's no, it's for the terminal. Oh, eLisp. Okay, that's what it is. So no, I'm not going to touch that. Beyond that, you have a daemon which has no code in it right now. Oh wait, what? Okay, that was weird. I think I might have a program somewhere that's actually compiling this in the background. Don't know. So the cargo terminal here is asking for, let's see, macros RT net signal. This looks, oh, this is Tokyo. Alright, so for people who are complete noobs like me, Tokyo is like the async runtime uh, for Rust. I know that from popular culture, not from actually having used it before. But this does actually have IR and IR log. IR log is another one of those things in IR which has beautiful, beautiful logs. Beautiful documentation. So I know exactly what it is, and it's importing the common library. Okay, so let's do a DFS and go into that and this just has IR. So I assume that's going to mean that this is like a library, which just has like library implementations. And okay, lib.rs seems to support that um, view of things. What's daemon eBPF? Uh, I actually don't even know where this is imported from. It's not imported over here. It's not imported over here. Interesting. This also imports the common stuff, and this actually has IIBPF. So I'm assuming that the actual um, XDP code would be in here. We haven't checked yet. We're discovering this together. And Xtask has absolutely nothing. Wow. Um, let's start with Xtask because it seems to have the least uh, dependencies. It has the most code, but seems to be the easiest place to start. Let's see. Uh, what are you doing? Command. Is this like? Is this literally a build tool or something? This literally seems to be a build tool. Am I going insane? Cargo X task. Oh, it is a build tool. Okay, interesting. I should have read the README. I didn't see that. And now this is heavy error. Anyway, so this is very helpful. So this shows that building the eBPF requires like you to call this Xstar stuff, and then the user space code is just cargo build, and then Xstar build does both. Interesting. I don't know if you can do this run step here because I assume this is supposed to be done on Mac, sorry, on a Linux, but we'll find out. And if it does actually require Linux, then I might have to set up like a virtual machine for that. We'll get back to that. Install the BPF linker. Cargo install. I did this already. Um, and we can just start running that, but before that, let's go through the code. So, where should we start? Let's start with the common library, which has nothing in it. That was helpful, and that means that I completely understand what daemon common is. And so do you. Um, now, let's go to the user space program, I assume. Okay, let's see what's happening here. There's a main function which is very helpful. And it's taking some options, it's parsing the options, it's initializing a logger. Okay, why it's needed for older kernels that don't use the memcg based accounting. Interesting. We might have to read that later, but let's say this is required for now. Unsafe code within the first minute of opening a Rust file, which is lovely. Libc set. Oh, I see. This is just calling this is called to actually make this happen, which is understandable. So this is called, so it's unsafe. Okay. If get is not equal to 0, then failed. Okay, makes sense. Okay, and then what are we doing? We are loading the BPF program. BPF load. These are ///target. I really don't like the fact that these use like relative positioning in these files, but that's something we can fix much later. Failed to initialize the logger. BPF load. Okay, so BPF load I assume just loads the BPF artifacts, the actual like VM assembly modules. It loads the files into memory or into these things. I don't know. Okay, so this is only run if it is debug. If it's not debug, it's loading. I see. Okay, cool. Again, Rust move. So I took a bit to understand what's going on here, but it's relatively straightforward. It's just An assertion, God damn it, it's an assertion saying that if it's debug, load the debug module, and if it's a release, or if it's not debug, load the release module. Relatively straightforward. BPF logger initialize. So this is just trying to initialize logger. Um, this can happen if you remove all log statements from your eBPF program. Okay, interesting. That means if you don't have like a log statement in your eBPF, like the logger itself fails to initialize. Cool. Um, and then you define a daemon program. Or you define a program called daemon. That's bad. That's going to lead to conflicts. So should probably name this something else. But we can figure that out later. And then, oh, this is the loaded BPF. This is what, damn it. Okay. Yeah, so this is the program that we loaded, and we are trying to define a mutable version, returns a mutable reference to the program with a given name. Used to get a program before. Huh. Okay. I think this is just syntax. I assumed that this is what this actually did, but apparently not. This is just literally reading the eBPF bytecode. It's literally just reading like the file. It's not making it into a program structure. It's making it into a program structure and then saying, okay, assume that it works, right? This is Rust shorthand for assume that it works. And we'll deal with, error handling and stuff later. And then you're trying to load the program and attach it to the options interface. The options are the things that we are passing into the program, if you remember over there, which all makes sense. All of this makes sense. Waiting for Control C. Again, later we have to change these signals into more standard signals, like an interrupt handling mechanism and stuff. But all of this looks good. And just in case you're wondering, like why we've attached a program, but we have not like stopped it at any point, it's because Aya actually takes care of that. So on exiting the program, Aya automatically like detaches your eBPF programs from the kernel stack, right? So we should be safe. So all of this looks very, very simple, understandable. It doesn't look like you have to change anything here for now. Later on, because this is a user space program, later on this is where we'll do the things that you don't want to do in the kernel stack. So for example, the kernel stack would actually produce logs. So if you remember the diagram which I showed a bit earlier, give me a second. Alright, so this thing automatically shuts down every once in a while, which is why it is currently not loading. I did start it again, but there you go. Cool. Right, so you remember how we produced these log messages. So all of these log messages would be produced in various different eBPF mount points, but you don't actually want to do log analysis in kernel space, because kernel space is very, very valuable. You want to do it in user space so that you don't actually impact the performance of every program that's actually running, right? So later on, when we want to do the actual analysis of those logs, we'll have to do it in user space over here, where we want to, like, once we have a policy, if we have like a policy centralization mechanism, because that will be very useful, right? Where we have like a central server or something that's actually storing all the policies. This is where we'll fetch those from and like renew your firewall rules, whether that's a push-based mechanism, pull-based mechanism, or whatever. That all comes later. But for now, this looks just fine, more than fine actually. This works. So let's go into the actual eBPF stuff. This is where I'm a bit scared. The code seems like there's not much here, which doesn't seem, which is scary, right? Like the more code you have, the easier it is to look through it and just understand what's going on. But this looks very simple. It looks like there is one try function, uh, and it's saying that I'm calling the try function with the full context. The try function literally just returns an OK with XDP pass, which I assume just means an accept. I know that there's documentation for this somewhere. Program lifecycle, oh no, it's probably over here. And XDP pass lets the packet continue through the network stack. Cool. So this looks very, very straightforward, right? And this is where we need to write our code to actually do um, to do the um, checking of whether the policies actually make sense and all of that stuff. Now, we might do that in a very intelligent way. Ideally, what we want to do is look at all the policies, compile it for that specific system, because your policies might have things like, hey, if this tag matches that tag, or if the current system is this tag, you don't want to check if the current system is this tag on every host, right? Because you can just take the ones that are relevant for that host and send those as in like a nice compiled fashion over here, and then this is just applying that, something like that. Now, I don't know if I've been able to explain that well. One of the many complaints that I get is that I don't explain things from like the ground up, but because this is just supposed to be a vibe of what's going on, I think I'll leave it at that. And when we actually get to the implementation, we will go ahead and explain that in a more deep format. But for now, I think I understand what's going on. So let's try to run this. I assume this is going to fail because it's a Mac OS and this is not supposed to be run on Mac OS. Yes. But let's try it. Cargo xtask build. I genuinely don't know if this works with. And expect I. Okay, it didn't work. Could not compile IR. Build failed. Okay, it's expecting the syscall to be I32, but it's found an I64. Yes. This is almost definitely because like a Linux versus Mac thing, because it's saying that, hey, unresolved imports of like libc stuff. Cool. Let's see if there's like a cross compilation stuff thing. Oh, there is. Okay. Cross compiling IR based programs on Mac. That's what we want. Custom stable install. Oh, I have all of this. I think Arches. Oh, because I need to compile it for um, x86. That's another issue, which makes sense. Okay, that might take a bit. I did this to install the Musil cross compiler. I don't want to install a Musil cross compiler. I want to use normal libc. But it looks like this is just targeting Musil, so it's fine. Let's do that. Okay, there's a brew thing. It's fine. Should have done that instead, actually. It's okay. Damn it. Install BPF linker. We did this already. And then we should just be able to do this now. And if these work, I just need to set up some automation on running this on like an actual Linux server, which I don't have. So I'll just go spin up like a box on DigitalOcean, something like that. It's just taking a long time to install. I did not assume that it would take this much time. Wasn't looking at that. That failed. Okay, where did you fail? Okay, so the AR64 thing, I'm gonna ignore. Right? Like, we just need that for now. Ideally, we would have uh, support for ARM, but wait, but it's not working. So what can we do? Chill. Let's do it. Hopefully this works. So it did. Okay. And I don't want the release version. I want the debug version. eBPF. And then the Rust flags need to say Linux, and then I don't want release cargo build. There you go. Hey, beautiful. Okay, cool. So we should have the ability to now run the I actually don't know how to run it. The cross compile program can be found over there. Okay, let's take a look. Right, should be in target debug build target debug. Oh, sorry, it should be in target x86 unknown Linux debug, and I should be able to run it using this xtask. So I did actually. I was able to spin up a DO instance at that time. Just go in there. Workspace hackathons. Fireball. Daemon. Now I should be able to cp -r dot slash say target x86 64 debug, I guess, and then I should be able to just I should definitely set up an alias for this, but I haven't yet because I literally just spun it up. But slash root. I don't know why I expected otherwise, but and let's make a program, make a file here, firewall, and again the reason we are not using like an actual host and just using like a random host that we're spinning up is because we don't know if the firewall is going to break access, and if the firewall breaks access, we don't want to lose an actual machine. Like, this is fine because it's just a machine that we are spinning up for the express purpose of testing this. Okay, now I should be able to do like a Rust. Oh, I should be able to like cd into firewall, cd into debug. Looks like it's taking some time, but should be able to do a Rust log equals info dot slash xtask run. It's probably gonna fail. It's fine. It has a lot of stuff. Do I actually need all this? I don't think so. I think I just need those. But now I started it. Might as well let it complete. Should probably have used something like arclone or rsync, but don't have that. So you're gonna wait with me while this finishes copying. Probably need to do chmod as well. A lot of object files. I assume all of these have been linked together into that static file. Have not even checked that actually. Let's do that. But meantime, cd should be able to just go up. And then let's try doing a so let's do adu ssh in here, and oh, it's actually pretty big. Oh, I didn't expect that to be that big. What do we look like? Most of the data is in depths. It looks like the daemon's actually being copied right now, so that's pretty good. I am bored, so I don't think we need to copy those folders, but yeah, I don't think we need this. Let's just run the exact same scp, right, without the minus r. Should now it should just copy the actual programs. There you go. And then should be able to as myself. Daemon is over here with execute permissions. Xtask, I expected Xtask to be over here too. Xtask was copied. Oh, probably over here. Yeah. So I didn't specify that. My bad. Alright, so it does have execute privileges. So let me actually open another session. SSH. Right? Because I don't know. I think this is gonna. Oop. Xtask run. No such file or directory. Why? Oh, this is actually doing the build. I don't care about that actually. So I should just be able to run daemon. That should work. Oh my god, it's receiving a lot of packets. Why is it receiving so many packets? Is this because of my SSH? I assume so. But let's see what's happening here, right? So over here, if I go to my daemon code, I can see that. There we go. That's where it's at. It's pretty cool. That means that this is actually working, and then Control C kills it. Cool. So we have like a basic, very basic, rudimentary setup for the actual packet filter stuff. Now, obviously, we'll do nothing with it, right? But, But okay, why are we not able to use this? CTX dot extract into variable. Okay, what's the shape of this? Come on. Do I not have the Rust plugin or something? I do. That's okay. I don't think I need to add that. Oh, balls. The power checker thing? I don't know. Well, we'll figure that out later. But it does look like we are receiving packets what we need to do next is actually figure out. Uh, I think I should write some tooling around actually automating this testing. Otherwise, it's going to be a little bit of a pain to do this each time. Uh, but doing that is actually relatively straightforward. I literally write a make file that'll the um, run the commands, copy the file onto our little test machine, and run the daemon. So I think this makes sense. What we need to do next is actually write the packet filter. Now I need to think about it a little bit. I will stop because it is 3, like almost 4 o'clock, and I need to go run, and then I need to go to the concert. But this looks promising right now, and next time we will actually get started with writing the plugin and building the firewall. And by next time, it depends on when the concert ends. If the concert ends at like 10, I'll skip out today. Otherwise, I try to do one more session today. I want to try to grind this out over the weekend. It'll be fun. Okay. I don't really even know why I'm recording this. Thought it'd be